Hey everyone, welcome back to our podcast. Today we are diving into a very important concept in the computer architecture that's actually a power a lot of modern technology. That's a Flames taxonomy. And to help us to understand this topic neatly, I have with me Ketki. So welcome Ketki.
Thank you so much. I am really excited to talk about this topic because this topic might sound theoretical, but actually it's used everywhere. From your smartphone to cloud computing, everywhere this concept is used.
That sounds interesting already. So even the apps we use daily are connected to this.
Absolutely. Whether you are scrolling Instagram, watching YouTube video, or you are using some AI tool, somewhere in the background this architecture is continuously working.
Oh, so let's start from its basic. What's exactly the Flames taxonomy?
So, Flynn taxonomy is a classification of the computer architecture and it is proposed by the Michael J. Flynn in 1966. Basically, it's depend on the instruction stream and data stream.
Okay, can you please simply tell me what kind of bit information you are trying to tell us?
Sure. So, basically, instruction stream means the commands which are executed on a data or the computer operations. Or the data stream means the actual data information which can be include numbers, images. On these the instructions are executed. So Flynn basically asked how many instructions are running or how much data is being processed now.
Okay, that's actually a very logical way to classify the systems, right?
Yes, exactly. And on the basis of this data and instruction stream, there are the four categories, namely the SISD, SIMD, MISD and MIMD.
Okay, why is the Flames technology still important today?
The Flynn taxonomy is important because in everyday life there are so many tasks which are parallelly operating. We are doing the multiple things at the same time. Suppose we are listening to music or we are chatting on a WhatsApp with our friends. On the same time we are downloading some kinds of file in a background. So we are doing all these same tasks at the same time. So yes, all these things are happen parallelly.
Okay, so right, whatever example you told just now, we do that every day.
Exactly. Flynn taxonomy helps us to understand how the systems and things manage all kinds of things very efficiently. It also helps in designing the processor, building a cloud system or improving the performance of all kinds of operations.
Okay, so let's start with your first type, that is SISD, single instruction and single data.
So basically SISD stands for the single instruction and single data. It name itself says that the only single instruction is executed at a single data atom at the same time.
So basically no multiple tasking, right?
Exactly. It works step by step. Only one process, one step initially at the same time. In our everyday life, many kinds of things are happen. Everyday life, there are many examples like basic calculator solving one problem. Here, the calculator perform only one task at a time. Old single core computer or simply simple embedded system like microwave or controller. Here, only one task is happening only at the same time.
Okay, that sounds very basic compared to today's systems.
Yes, but it's still important because it forms the foundation of this architecture. This SISD architecture or the system having some kinds of feature like it having the only one CPU, it having only one memory and the operations are happen sequential. Coming towards it disadvantages, it having advantages like it having the simple design. Means we can easily understand or build, implement this architecture. Then it having the low cost. Like I already told, it having the simple architecture, simple design, so it having the low cost. Then easy programming. We can easily find out the errors. We can debug all kinds of things very straightforwardly. And coming toward the disadvantage of SISD architecture, it having disadvantage like no parallelism. Means we cannot perform the multiple tasks simultaneously. We can perform only one task at a time. And it having the slow performance. Like we cannot perform the task very fastly, or if we want to perform the task, it will take a longer time.
So SISD is like doing the homework on particular one question at a time, right?
Perfect analogy.
So I think that's enough. Now let's move to your next topic, that is SIMD.
Okay. So SIMD basically stand for the single instruction and multiple data. Means here is only one instruction or only one command is executed on the multiple data type, and these data types are the same kinds of data type.
Okay, that sounds good, but can you give me an easy example regarding this concept?
Yes. Imagine you are uploading a story on Instagram and there is your one picture. Then you are applying some kind of filter or some kind of effect on these photos. So here only one filter or only one effect is applied on the similar kind of all pixels. So it's come under the SIMD architecture. In our real world example like Instagram filter, video rendering, training of the various kinds of AI model and GPU in gaming rendering, all kinds of things are come under the SIMD.
So as you told in the example, that is GPUs in gaming. So GPUs are used in SIMD?
Exactly. GPU are designed for this type of parallel processing. It having the some kinds of features like it having the only one control in it, and there are the many processor used to perform the multiple tasks, and it having the same instruction on the different types of data items. Coming towards its advantage, it having the high speed means we can perform the process a large amount of data items simultaneously. It is efficient for the AI, like we can easily calculate the matrix calculation and we can put it in the matrix. It is energy efficient, like if you want to perform the task and if the task required the many power, then we can perform the task with minimal power requirement as well with the help of this architecture. Talking about the disadvantage of this architecture, it having the less flexibility. Like we can perform the only one task at a time. We cannot perform the different kind of task at the same time. And it is not good for the irregular problems. Means, as I told earlier, the same kinds of the data instruction is applied on the same kinds of data item. The similar data items come under this operation.
So SIMD is like a teacher who is giving the same question to the entire class, right?
Exactly. And every student must solve to this problem at the same time.
Okay, that sounds interesting. Now MISD, this is the one of the confusing among the all, I think, right?
Yes. So MISD stand for the multiple instruction and the single data. Here are the multiple processors are operated to perform the multiple operation. And here is the different instruction and the same data. Means the different instructions are executed on the same kind of data items.
Okay, so why would we need that?
So basically this architecture is required for the reliability and the safety. In the real-time example, suppose there is aircraft system and we want to check some kind of data, then this architecture is used for that. Then again, the nuclear plant for the monitoring system and the defense system also use these kinds of architecture.
So it's like double checking, right?
Yes. Actually multiple checking.
Okay.
So this architecture having some kind of features like here the same data is processed the multiple times through the multiple processor. Different algorithms are used to process to check this data whether the data is the correct or the not. And as the multiple time checkings is the occur, this architecture is highly reliable among all these architecture. Coming towards the advantage of this architecture, it is highly reliable. As I told earlier, we are here checking the same data item multiple times through the multiple processor. Multiple times this operations takes place. That is so it is highly reliable among all architecture. And it also having one of the more advantage that error detection. We can easily detect the error in this architecture. We can find out the different output compared with the another output. And coming toward the disadvantage of this system or the architecture, first one is the complex design. Means compared to the rest of the architecture, it is difficult to implement as well as for the user perspective, it is difficult to understand. It is very expensive as the structure of the design itself is the very complicated, so it required the large amount of the cost to implement all this. That is so it is highly reliable among all architecture. And it also having one of the more advantage that error detection. We can easily detect the error in this architecture. We can find out the different output compared with the another output. And coming toward the disadvantage of this system or the architecture, first one is the complex design. Means compared to the rest of the architecture, it is difficult to implement, as well as for the user perspective, it is difficult to understand. It is very expensive, as the structure or the design itself is the very complicated, so it required the large amount of the cost to implement all this kind of thing. And the rare assets means compared to the remaining architecture, we cannot implement it practically.
So I think after knowing its advantage and disadvantage, it is only used where the mistakes are not allowed.
Exactly, life critical system.
Okay, so let's move to the most important one, that is an MIMD.
Yes, so basically MIMD stand for the multiple instruction and the multiple data. Its name itself indicates that here are the multiple instruction, that is the multiple commands are executed on the multiple data items at the same time. It having the multiple processor for performing the multiple operation, different instruction, that is the different commands and the different data items as well.
So this is the real multitasking, right?
Exactly. This is what power modern system. The real life example, like we are using the multiple apps on your phone, like we are using the WhatsApp, we have opened the YouTube, or we are listening the music as well, or like the online shopping website Flipkart, Amazon handles the thousands of the user at a time. Means many users are on that website. Some are ordering, some are creating the account. All these things are comes under the MIMD architecture. Similarly, the streaming platform like Netflix, or the cloud platform like Amazon Web Service, Microsoft Azure, Google Compute Engine, and it having some kind of feature as well, like it having the multiple CPUs, it having the independent processing, and it having the shared or the distributed kind of memory. Coming toward the advantage of this architecture, it is highly scalable compared to the remaining architecture of the system. Like we can easily increase or decrease the number of the processor, we can handle the workload very easily. Then the flexibility means the different tasks or the operation performed simultaneously. And also the task parallelism means the multiple operation is working at the same time. And coming towards its disadvantages, it having the one of the major disadvantages like the complex synchronization. Like as there are the multiple processor and these all multiple processor are performing the multiple operations, so it is the hard to coordinate among all these processor. Then the deadlock. Here as the multiple processor work on the multiple operations, some kind of process may block the each other. Means whether the process, suppose there are two process 1 and process 2, there is the might possibility that process 1 might block the process 2 while working is happening. And high cost, as it having the complex architecture, many kinds of hardware are involved in this. It required a large amount of cost for the implementation and the building.
So as per your information you gave us, I think this is only makes the cloud computing possible.
Exactly. Without the MIMD, that is the multiple instruction and the multiple data, modern cloud system wouldn't exist. So it is the one of the important architecture among all the Flynn taxonomy architecture of the system.
I just as a last request, can you quickly compare all these four kind of types you just discussed with us?
Sure. So SISD, that is single instruction, single data, it performs the only one task at a time, like the calculator solving the problem. And the SIMD, that is single instruction, multiple data, the same task is operated on the multiple data item, like Instagram filter on a picture. And MISD, that is the multiple instruction and the single data, multiple checks on the same data, that is the multiple instructions are executed on the same data, like in the nuclear power plant the safety checking is occurring. and the MIMD, that is the multiple instruction, multiple data. The multiple tasks, multiple operation are executed on the multiple data item. Like we are seeing the video on the YouTube, we are chatting with our friend, we are downloading the music from the Spotify. All are comes under the MIMD architecture.
So that makes a clear picture in the mind. So where do we use this Flynn taxonomy today?
So basically Flynn taxonomy is used in the various kinds of area in day-to-day life. In the cloud computing, like the server handling the multiple users, their requests, they are providing the services to the user at the same time. Then in the artificial intelligence, then supercomputer as well, and the big data system for the processing and checking the accuracy of the data by using the different algorithm. In the AI, basically the SIMD, that is the single instruction multiple data is used, which is including the GPUs rendering in gaming. Then the cloud, basically the MIMD, that is the multiple instruction and the multiple data is used. As the cloud is providing the services to the multiple user at the same time, so there are the multiple operation happens in the background, and for that multiple processors are the required. So it is the very beneficial that the cloud using the MIMD architecture. And in the safety system, the MISD, that is the multiple instruction and the single data is used, like in the nuclear power plant or in the aircraft control system as well. The MISD architecture is very important.
Okay, that was great to hear everything about your topic. So what are the overall benefits? Can you please tell us?
Sure. So overall benefits of this Flynn taxonomy is it support the parallel computing, means it speed up the processing on multiple tasks and multiple operation can run at the same time. It improve the performance as the multiple processes are performed simultaneously. So overall performance of the system or the architecture is the increases, and also the reduced execution time. Means suppose there are the two processes, and initially the suppose process P1 is comes under the execution, it will take some amount of time, and later the process P2 comes for the execution. Then both require the different kinds of time for the execution, but instead of this, suppose we perform the process P1 and the P2 simultaneously, then it will take the minimal time for the execution. Then it enables the scalability, means the basically Flynn taxonomy is the most scalable system. We can easily increase or decrease the number of the processor as per our requirement, as per our need, and also we can perform the operations scalably as per our need. And last is the support AI and the big data. With the help of this Flynn taxonomy and the architecture, we can handle the large amount of data set, the multiple data set or the vast amount of data set can process, and we can check the accuracy of this data set as well.
So after knowing its advantages, disadvantages, its real-time uses, now also I would like to ask, are there some kind of challenges or issues regarding this technology?
Yes, the Flynn taxonomy basically faces some kinds of challenges, whether it can be the technical or it can be the ethical. In the technical, first is the synchronization, means it is difficult to coordinate as there are the multiple processor, multiple operation and the multiple tasks. Sometimes all these tasks are happen simultaneously, so it is difficult to the coordinate with each other. It might faces some challenge of the coordination with the processor itself. And another one is the deadlock, like system may freeze or the process may block the another process. As the multiple processes are executed simultaneously, the one process might freeze the another process. And along with some technical challenges, there are some ethical challenges as well, which the Flynn taxonomy facing. The high energy consumption, because the mostly huge amount of data centers having the huge amount of data, and all these data center require the processing of this data through the multiple processor or performing the various kinds of operation, and it required the large amount of power basically to perform all these kinds of operations. So one of the important ethical challenge that the Flynn taxonomy faces is the high energy consumption and the environmental impact. that it affects sustainability. As I told earlier, there are the multiple processor, operations, tasks which are performed simultaneously. There are the many data center with their own data and they require the power for this operation. So if the large amount of power is required for this operation, it may hamper the environmental sustainability. It can affect the sustainability.
Okay, that was great to know about its issues and challenges as well. So, can you please quickly summarize everything for us?
So basically, the Flynn taxonomy concept is a very vast concept. As I told you earlier, there are the 4 categories. Each of the category having some different feature, advantage, disadvantage, and some real world examples. So it is quite difficult to summarize all these things in a short glimpse, but I'm trying to do it. Sure, I can summarize it. So basically, the Flynn taxonomy having the main 4 categories: SISD, that is single instruction, single data, which is a very basic system. Here, the only one instruction is executed on only one data atom at a time. Like the solving the problem through the calculator, here we are trying to solve the only one mathematical operation at only one time. Then the next one is the SIMD, that is the single instruction and the multiple data. Here the only one instruction is executed on the multiple data atoms at the same time. Like Instagram story, where the same kinds of effect is applied on the multiple data atoms. It comes under the AI and the graphics. Then the MISD, that is the multiple instruction and the single data. Here the various kinds of instructions are executed on the single data atom, like the nuclear power control system, which is used to checking its safety, and the MIMD, that is the multiple instruction and the multiple data. Here, as its name indicates, that the multiple instructions are executed on the multiple data atom. For example, in the cloud computing, the cloud computing handles the multiple data center, multiple user, and provide the services for these multiple user at the same time. So basically, MIMD is the backbone of the cloud system, which is very important to smoothly run all or various kinds of operation in the cloud. And the SIMD, it is the power of AI.
That was an amazing explanation, Ketki. Thank you so much that because of you we get a huge knowledge regarding this new concept that is a Flynn taxonomy. Thank you once again.
Thank you. It was a great discussion with you, Tejal.
And thank you everyone for listening. Stay tuned for the next interesting topic. Thank you.
Thank you.